Gravity, the force that governs the motion of celestial bodies, has fascinated humans for millennia. From the ancient Greeks pondering the nature of falling objects to Isaac Newton's groundbreaking work on universal gravitation, humanity's understanding of gravity has evolved significantly. In this comprehensive exploration, we delve into the intricacies of gravity, its historical development, its role in the cosmos, and its implications for our understanding of the universe. Historical perspectives on gravity. The concept of gravity has ancient roots, with early civilizations observing and attempting to explain the phenomena of falling objects. Ancient Greek philosophers, such as Aristotle, proposed theories to explain why objects fell towards the earth, suggesting that objects had a natural tendency to seek their natural place at the center of the universe. It wasn't until the 17th century that Isaac Newton formulated the first comprehensive theory of gravity. In his seminal work Philosophiae Naturalis, Principia Mathematica, Mathematical Principles of Natural Philosophy, Newton introduced his law of universal gravitation. He proposed that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. This law provided a framework to understand not only the motion of objects on Earth, but also the motion of celestial bodies in space. Newton's theory of gravity revolutionized physics and laid the groundwork for centuries of scientific inquiry. However, it wasn't until the early 20th century that Albert Einstein's theory of general relativity provided a deeper understanding of gravity as a curvature of spacetime.
The topic of this lesson is the weight of objects on Earth. We will start with the definition of gravity. What is gravity? It is a fundamental force of nature that affects every object on Earth. It determines the weight of objects and plays a crucial role in our everyday lives. Understanding how gravity influences weight is essential in various fields, from physics and engineering to health and sports. Let us discuss some terms. In order to understand the lesson, the first thing to consider is gravity and weight. Gravity is the force of attraction between objects with mass. On Earth, gravity pulls everything towards its center. The weight of an object is the force exerted on it by gravity. Weight is directly proportional to an object's mass and the strength of gravity. Mass versus weight. Mass and weight are often confused, but are distinct concepts. Mass is the amount of matter in an object and is measured in kilograms, kg, or grams, g. Weight, on the other hand, is the force exerted on an object due to gravity and is measured in newtons, N, or pounds, lb. For variation in weight, the weight of an object can vary depending on its location. Objects weigh slightly less at higher altitudes because they are farther from the center of the Earth, where gravity is slightly weaker. Conversely, objects weigh more when they are deeper underground due to being closer to the Earth's center. 5. Units of weight. Weight is commonly measured in newtons, N, or pounds, lb, in the metric and imperial systems, respectively. It is essential to use the appropriate units when discussing weight to avoid confusion. 6. Weightlessness. In environments where gravitational forces are negligible, such as outer space or during free fall, objects experience weightlessness. This doesn't mean they have no mass, but rather that there is no force acting on them to give them weight.
Now, we are going to continue with the topic, weight of objects on Earth. We started with the definition of gravity and consider some terms relating to gravity and weightlessness. Let us continue from where we stopped in our last lecture. 7. Practical applications. Understanding the weight of objects is crucial in various practical applications. In engineering and construction, it is essential for determining the load-bearing capacity of structures. In sports and fitness, weight plays a significant role in training and performance. In medicine, monitoring weight is essential for assessing health and managing conditions such as obesity. 8. Historical perspective. The concept of weight and gravity has been studied for centuries. Ancient civilizations such as the Greeks and Egyptians observed the effects of gravity but did not fully understand its underlying principles. It wasn't until the time of Sir Isaac Newton in the 17th century that gravity was mathematically described. 9. Beyond Earth. While weight is a familiar concept on Earth, it varies on other celestial bodies. The weight of an object on the Moon, for example, is about 1/6 of its weight on Earth due to the Moon's lower gravity. On the other hand, objects would weigh much more on Jupiter due to its stronger gravity. In conclusion, understanding the weight of objects on Earth involves comprehending the fundamental principles of gravity, mass, and the relationship between the two. It is a concept that has practical applications in various fields and has been studied for centuries. By understanding weight, we gain insight into the forces that govern the universe and our place within it.